My name is Graham Kerslick. I'm the Executive Director of the Atkinson Centre, and on behalf of the Director, David Lodge, welcome. It's a pleasure to introduce Natalie Mahowald, who's a speaker today. Natalie is the Irving Porter Professor of Engineering in the Department of Earth and Atmospheric Sciences. She's also a Faculty Director at the Cornell Atkinson Centre for a Sustainable Future. She's a Fellow of the American Meteorological Society and the American Geophysical Union. She was an author on the 5th assessment report for the working group number 1 within the IPCC. And more recently, she was an author on the recent UN special report. And in fact, that's what she's going to talk to us today about, what's new in the special report. Natalie, welcome.
Well, thank you very much. Thanks for coming out tonight and listening to me tell you a little bit about the most recent report, the special report on 1.5. I am a faculty member here, but part of my role today is actually to disseminate information from the IPCC, the Intergovernmental Panel on Climate Change, which put together this report. And so you can see here actually the kind of official looking background for this PowerPoint, and that is what IPCC put together. And so as a lead author on this report, and I was also a contributing author on the summary for policymakers, I'm supposed to go out and broadcast the report and really talk about what the report says, the synthesis report, and this, it's really a consensus document. So most of what I'm going to say here today is going to be kind of official Intergovernmental Panel on Climate Change results. As a lead author, I'm going to present that. And you're going to see that. It's going to be the official PowerPoints. I am going to have a few slides that I kind of threw in there that I think provide really good context, but are not officially part of the presentation. So there's going to be a little of that. But for the most part, I'm going to stick with what the consensus view is instead of my own personal scientific views for this talk. So the report that we were asked by the UN to write is, it has this very long title here, you know, a special report on the impacts of global warming of 1.5 degrees C above pre-industrial levels and related global greenhouse gas emission pathways in the context of strengthening the global response to the threat of climate change, sustainable development, and efforts to eradicate poverty, okay? First of all, it's a huge, long name, all right? So there's really good reasons for that. But in that name, there is, I think, one of the really important elements of the whole climate change debate that I feel like aren't always, or it isn't always fully recognized by people who may be very concerned about climate change, but not understanding really the focus of the problem. Here in the US, we often pose climate change as a business versus environment problem, okay? And that might be somewhat true in the United States, but most of the climate change problem in the future actually has to do with development and eradication of poverty versus climate change, okay? Most of the future emissions of carbon dioxide are gonna come from developing countries trying to get the lifestyle that we have. We are a developed country. We got rich, all this technology we have here, using cheap fuels and cutting down every forest we want and emitting CO2, okay? And the rest of the country and the rest of the world wants to eradicate poverty and live like us, okay? And, you know, that seems like a fair thing for them to not have to live under poverty. But that's really what the climate change issue is about. It's not just about environment versus business. In order to solve the climate change problem, especially with such a low level of warming of 1.5 degrees C, it's going to be super hard to not prevent development, okay, from countries. What we have to do is figure out a way, a cheap way to develop that is sustainable and just as cheap as what we did, you know, burning fossil fuels, okay? And this is a really, really hard problem. And this is already here in the title of this special report, and that's somewhat deliberately. Now, the other part that I find that people really don't understand about the climate change problem is the sheer scale. There actually are seats over here in the back. There's more than 5 seats over here in the back. Is the sheer time scale of the problem. We are emitting so much CO2 right now, and there are so many humans on this planet, and it is so intrinsic to our way of life that it's going to be really, really hard to switch over to something where we don't emit as much CO2 as we are today. What I think a good way to think about it is it took us 250 years to get to this point, and it's going to take us 50 to 100 years, if we're lucky, to get out of this problem. It is not a short-term problem. The climate change problem is a very long-term problem. So I do want to start with something a little bit positive, and that is that humans have actually, over the past 20 to 50 years, been pretty successful at eradicating poverty, okay? And not just in relative numbers, but the actual absolute numbers of people living in extreme poverty has actually been going down over the last 20 to 50 years. We have not been particularly successful at addressing climate change, but we have been successful at limiting extreme poverty. So there are some positive things, but there is that trade-off between eradication of poverty and climate change that we need to move beyond in order to try to address the climate change problem. So to provide a little bit of context for this, I just want to say that this report is done by the IPCC, the Intergovernmental Panel on Climate Change, and that is jointly organized by the Environment Program of the UN, as well as the World Meteorological Organization. And what happens in these reports is they're written by scientists, like myself. I represented, not Cornell really, but the US during this procedure, and was an author. And then the governments accept the summary for policymaker part of it, line by line. So we wrote something like it's 400 word pages document, and then we summarized that into about 30 pages in a Word document in the summary for policymakers. And that's the part that the governments accept line by line during a particular session. So I'm going to talk to you a little bit about how these reports are made and what it feels like as a scientist to be involved in this kind of process, because I think it's interesting. This work is done under the UN, or in relationship with the UN Framework Convention on Climate Change. Just yet another acronym. Anyway, so again, this is one of the slides we're supposed to show as part of this IPCC special report, and that is there were 91 authors from 40 countries. So I was nominated from Cornell, or really I nominated myself, and then the US, Cornell moved me to the US nominated me. And then at that level, the IPCC, there were over 1,000 scientists nominated, and I was one of the 91 authors of the 6 Americans who were chosen to be on the report. And so there's 40 countries represented. There's 133 authors were brought in. I mean, this is a super broad report, right? We're supposed to address sustainable development, eradication of poverty, and climate change. Extremely broad. Very broad group of scientists was incorporated into this report. And that also meant that we needed more contributing authors to be able to represent all the areas. Before this report was done, there really were very few studies about 1.5 degrees C, okay? The countries actually had to ask for this report specially. This is the only report that the governments have actually requested before. And it focuses on 1.5 versus 2 degrees because 2 degrees is the lowest we've ever considered before in the IPCC reports. And the reason is that 2 degrees is already really, really ambitious, and 1.5 is even more ambitious, okay? But some of the countries, most specifically the countries that will cease to exist because they'll go underwater, the small island developing states, wanted to see what it would take to keep warming below 1.5, and what the difference between that and 2, which is what has previously been considered within the IPCC. So they directly asked us to look at this 1.5 versus 2 degrees in the reports. There was almost no studies associated with that before we started. So there was a huge number of new studies that were done looking at 1.5 versus 2. And so we included 6,000 studies basically in this report. There were over 1,000 reviewers and then 40,000 comments, and we had to respond to each one individually. So these reports are not just one person's opinion. That's the important part. These are consensus reports. So my favorite science is not in this report, by the way. It has to be reproduced by many, many scientists in order for it to get into a report like this. Okay. So the process for the IPCC reports are there's a scoping meeting that outlines what's going to be in the report. Then the governments actually approve the outline. And so this is a little bit of a question of importance when we come to approve the summary for policymakers, because if there's a politically sensitive issue that the governments do not want the scientists commenting on, for example, how to calculate costs, mitigation costs or loss and damages, all of that, the governments will nix it from the outline and then insist that we remove it from the report, in the report. They simply don't want the scientists doing policy. Okay, that's not part of the IPCC. We are supposed to present the case. If this happens, this will happen, so the policymakers can make decisions. We are not allowed to be policy prescriptive in the IPCC framework, okay? The UN negotiators from each country want to be doing all the policy, not us. So that's a really important distinction. So the governments then agree. Oh, okay, so then, so that's the approval of the outline. Then the authors are selected. Then there's 3 drafts that are out for review from experts as well as governments. And so this particular report was done very quickly, 1.5 years. Most reports are done over 4 years, and with expert review. And again, that's the 40,000 reviewer comments. And then we also get the government comments as well. Then at the very end, we do the approval session, the government approval session. This was done October 1 through 5 this year, this academic year. We're supposed to be done by Friday at 7 p.m. The sessions were originally 10 a.m. to 1 p.m. and then 3 p.m. to 7 p.m., which sounds super reasonable, doesn't it? And these are, really huge sessions, and they're UN sessions, so you've got the little thing in your ear so you can hear all the different languages, right? They've got simultaneous translation and all of this going on during it. Now, we already knew that we wouldn't get done over the normal time frame. They never get done over the normal time frame, so they actually ordered in extra interpreters so that we could do extra sessions. And then, so Wednesday they added an evening session, 8 to 10:30 p.m. Thursday they added a night session, 11 p.m. to 2 a.m., but which didn't have interpreters. And then Friday we went all the way straight through to Saturday at 3 p.m. Okay? So this one went longer than most of them do, but people expected everything to be done at the last minute. This is just how these go. So what the governments are doing is line by line going through the summary for policymaker and agreeing that each line represents the science in the underlying report that the scientists have put together and written up, and in the underlying science and papers underneath it. So that the summary for policymakers is reflecting the peer-reviewed literature, okay? And so that's what the governments are approving. They're not approving that they actually agree with the science, they're just approving that the scientists have correctly presented the science in the report. So it's kind of an interesting process. I mean, first of all, here you start with 91 scientists. I only knew a handful of them to begin with. This was an especially interdisciplinary group of people. It's always people from all different countries. And then we're producing this extremely cross-disciplinary report. And so, whenever you work cross-disciplinary, you have to redefine all your words and make sure you're super precise. And this was actually the first report that's ever been done across 3 working groups, so even more diverse than usual. And for example, impacts actually mean something different to a working group 1 person, who's like me, versus a working group 2 person, okay? And I won't go into all the semantics, but, so we decided to use the working group 2 definition, but people, from working group 1, we often will accidentally use working group 1 definition. And then we have to rewrite all the paragraphs when we realize, we've used the wrong definition. And so, and that's just a simple kind of example, but this happens all the time in the literature that, you're looking at one set of literature uses this word this way, and this set of literature uses it that way, and then you have to somehow get those together. And then when you put it up for the summary for policymakers, you've got to put it into layman's terms, okay? Even harder. I mean, you can talk about transitions and transformations, and this has this meaning in this literature, and that meaning in that literature, and it means something totally different to layperson. So it's a very interesting process trying to get everybody on the same page as to what the scientific literature really means when communicated to a policymaker. Okay. By the time you're done with all these meetings, you're best friends with at least half of those 91 people that you've never met before. So it's a very much a bonding experience. And at the end of the, 3 p.m. on Saturday, I was hugging the government negotiators too. Okay, we haven't slept for several days and just got the thing approved. Okay, it was very exciting. I wasn't sure that we were going to get it approved, to be honest. So just to tell you a little bit more about it, it's a huge room here. There must have been hundreds of people in the room. Here I am talking right there. It was in South Korea. Here's some of the co-chairs who lead the whole exercise. And I'm just presenting as an author. I come up front and I'm describing and defending what this bullet point and headline statement that we're trying to make in the summary for policymakers, what it is, why it is that way, just trying to convince the government that it correctly reflects the scientific literature. So we read the statements first, try to approve the bullet points under the headline statements, and then come back and get the headline statements. So then the co-chairs who are leading this, the IPCC co-chairs, and there's 6 of them, they'll open up different parts of the document and ask for interventions from the governments, okay? And so then the governments will, say, I don't think that word correctly reflects the scientific literature because of blah, blah, blah. Or that's, too vague, you need to refine that. There pretty much was not one sentence that made it through, okay, without being edited. And then we would, especially by Wednesday, we had gotten nothing approved by Wednesday, okay? We're halfway through, we've got nothing approved. So the co-chairs would actually just open up huge sections of text, start getting, comments from the governments, try to figure out what the biggest objections were, and then send people out into the hall together to do huddles, informal huddles. And so then you'd have the authors there, and then the government representatives trying to talk about what the text should be. Now, all of the discussion has to be on a scientific basis, although it can sometimes be very clear what the political motivation is of that science that government is arguing for. But it's all on a scientific basis, or whether or not it's in the scoping outline. That's the only things you can debate, okay, in this context. And then we would also sometimes have to have contact groups, which were formal organizations, which were actually led by governments. So there'd be 20, 30 people in another room, with people raising their hand and proposing different ideas. Now the authors have the final say on what the text says in the summary for policymakers, but the governments at the end have the choice to approve or not approve, and the governments have to reach consensus on each statement. So basically you can see that there's a ton of negotiation going on through the whole process. So like I said, we went all the way through the night. To be honest, I'm not supposed to talk about internal processes, but we pretty much got everything through we as scientists wanted in there. Some sections were heavily edited that were very political. Anything with money and the international cooperation, for example, was very controversial. We knew which sections were going to be controversial. But we pretty much got everything through, all our figures and everything. We were very happy with it. This is us, after 2 days of not sleeping. This is the author group, and here's the co-chairs here. This is me here. So this is the group of people who got the summary for policymakers through, so it's a smaller group. So it's a very interesting experience of where science meets policy here, and where you're actually talking to governments. And some of the time I was just super confused what the governments were objecting to. But most of the time, the final text was much clearer, okay, than the original text. I mean, these are negotiators, and their English, even if they're non-English speakers, was actually really very good. So it was a very interesting experience. All right, So to come back to this topic here, now we'll talk about what the science is that came out of this report. Like I said, the really important part of this report was that it was called for by countries. It's the first time any report that the IPCC has done has been requested specifically by governments. And they really wanted us to look at this 1.5 versus 2, because 2 was the lowest that we've ever looked at within the other assessment reports. There are a lot of different reports done by the IPCC. The normal assessment approach is the working group 1 does the physical climate system. I did the 5th assessment report on that, and it's a huge document assessing all the literature. And there's one on working group 2, impacts, vulnerability, adaptation, risk, and working group 3 on mitigation issues. Okay, this is the normal IPCC assessment approach that occurs. Like I said, previously we hadn't considered anything lower than 2 degrees, keeping climate change lower than 2 degrees. And even that was somewhat controversial because it's very difficult to reach it, to keep warming below 2 degrees. But we were requested to look at 1.5 versus 2 for this report. We were not requested to redo anything else except for what was in the outline. This is a special report, not a full assessment report. So there were all sorts of restrictions about what we could talk about or not talk about. And right now there's 2 other reports. There's the cryosphere and oceans, and then a land report going on that'll be finishing. Those are 2 other special reports. And the 6th assessment reports of these big things has started up, okay? And so then they'll reassess the whole literature. So there's just a ton of assessments going on from the scientific perspective. And I have to say the scientists this is a huge amount of resources that we spend doing these assessment reports. And so we usually request that they stop doing so many, whereas the governments want more, okay? So it's always this tension, and so the full assessments happen about every 7 years. Okay, so that was kind of the procedure and what goes on here. And so the main thing I want you to get out of that is that it is a consensus report. We have certain restrictions, and you can't slide anything in there, okay? It's got to be super robust, because a lot of people have read all the papers that you're referring to and talking, trying to place it in the context here. So the first section, the understanding what global warming at 1.5 means and where we are now, that was actually the section that I was writing the underlying chapter for that. And the important thing is that since pre-industrial times, human activities have caused approximately 1 degree of global warming at this point. We're already seeing consequences for people, nature, livelihood. And if we keep going at the same rate, we're going to reach 1.5 about 2040. But past emissions alone do not commit us to 1.5. It is physically possible to keep the temperatures below 1.5 at this point. So here's a figure showing the rise in temperature, average, here's the monthly mean temperatures, but then average. And if you just extend that, at about 2040, you'll reach 1.5 degrees. So we don't do anything. We keep going with the CO2 at the same rate as right now. We'll pass 1.5 at 2040. And then in this section, we talk about some kind of theoretical ways to keep temperatures stabilized there. But I'll skip that for now and talk about just a couple of concepts that are really important for the report. And that is, here we are, 2010, here's our radiative forcing and warming relative, to pre-industrial. And there's a lot of ways we can stay below 1.5, and one is, just kind of come close to it. Another one is to overshoot, that's that blue line, we go up and over, or we could come back down again. And if we overshoot like that in temperature, we're also overshooting in CO2, since that's our primary constituent, and that's what we're talking about there. So what happens if we reach 1.5 versus 2.0? One of the really important things that happened in preparation for this report was a lot of scientists started looking at small differences in temperature. What can we tell the difference between 1.0 and 1.5 and 1.5 and 2 degrees? Because, we're scientists. We like to have a really big signal to noise ratio. So normally when we're looking at impacts, we look at a business as usual scenario, which is 4 degrees C at 2100. And we just pound the system, and this is what the differences are. So there had been much less work on thinking about what would happen with lower temperatures, and especially 1.5 versus 2, because that's not one that we've been looking at that much, because frankly it's just very, very hard to keep warming below 1.5 or 2 degrees. But a lot of work was done for this report, which shows that actually we can see the difference in extreme events in what people are going to experience between 1.5 and 2 degrees. That it's going to be statistically significantly different, and humans are going to be impacted by it. So, some of the statistics are 10 centimeters lower, right? That's 3 inches. May not sound like much unless you live on the coast, okay? And then it starts sounding like quite a bit. And 10 million fewer people at risk from rising seas. There's a lower impact on biodiversity and species, smaller reductions in the yields in some of our key crops, and there's much less of the population that's going to be subject to water shortages. So it is really an important difference. Fisheries are going to be less at risk, and you're going to have several 100 million fewer people exposed to climate-related risk from poverty issues associated with repeat extreme events hitting them or other issues. It's a lot of people that would do better if we limited the warming to 1.5 versus 2 degrees, if we only consider the climate-related impact. Some of what was done in this report was really focusing on new evidence about some of these. This is called the reason for concern graph, which if you've looked at any of the recent IPCCs, they always have this kind of graph where, white is we can't really tell the difference, yellow is it's not very good, red is this is really bad, okay? This is too much of a change. Unique and threatened systems are going to be the coral reefs and Arctic regions. Extreme weather events, those increase under higher temperatures, the distribution of impacts and global aggregate impacts, and then the chance for a large-scale singular event. So for this report, we only we're focusing on 1.5 versus 2, but just to remind you, this comes from the last assessment report, and here they go up to 5 degrees C, because that's a business as usual if we don't really get ourselves together. So it's not that these risks went away anywhere, it's just that for this report we were focusing on 1.5 versus 2. So the thing to remember is we could tell the difference in small changes in temperature, and the higher the temperature goes, the worse the impacts are. And so we want to keep the temperatures as low as we can to prevent climate-related risks. There was also, a little more work and more studies, for example, looking at warm water corals, because there have been some more bleaching events, so we know a little bit more about the statistical significance of that in some other areas. So there's a little more detail also in what the impacts are in this report than previously had been. So how in the world do we keep the temperatures below 1.5 or 2 degrees? What kind of transitions does this require? So the really important thing to recognize is that we have to start cutting CO2 emissions right away, or yesterday, maybe is more accurate, 10 years ago. Okay, to limit warming to 1.5 degrees, CO2 emissions have to fall by about 45% from 2010 values by 2030. So in the next 12 years, we have to cut emissions by almost 50%. That's much more than we would have to do if we were going for a 2-degree target. To limit warming to 1.5, CO2 emissions would need to reach net zero at around 2050. Okay, so we have to stop emitting any CO2 at all by 2050. There are, if we stop burning fossil fuels, we actually also stop emitting aerosols and stop causing ozone. So there's quite a few health benefits, air quality health benefits associated with this also. limiting warming to 1.5 would require changes in emissions and land use as well on an unprecedented scale, okay? Much more than we've ever done before. We have to have deep emission cuts in all sectors. We have to use a range of technologies. We have to include behavior change. And we have to really start investing in low carbon options already. We have actually done really well in the energy sector in terms of developing new technologies. We have renewables, we have solar, we have wind, these have been developed. This is not true for the rest of the sectors. We don't have low CO2 options for all the rest of the sectors. We need to develop them. Now the energy sector is one of the most important, but we don't have options in the other sectors. So this is one of the problems with trying to transition to a low carbon economy. So we probably are going to have to start taking carbon dioxide out of the atmosphere instead of emitting it. You know, our whole way of life right now, everything we do emits CO2. You know, we cut down trees, we plant new agriculture. All these things are emitting CO2. We need to stop that and start sucking down CO2. And all these actions that we might take to cut the CO2 have implications for food security, ecosystems, and biodiversity, of course. If we're going to start reusing land in a different way, we need to really be thinking about the biodiversity demands as well as food security. So to be a little more specific, of course, under the Paris Agreement, the countries voluntarily put forward what they would agree to do, okay? The voluntary national, the NDCs, nationally determined contributions. Those pledges, although the government said, wouldn't it be great if we kept below 2 degrees, and wow, 1.5 would be awesome. What they pledged to do is actually consistent with this 3-degree rise in temperatures. Now, this is awesome because otherwise we're going to 4, okay? So this is awesome, don't get me wrong, but it is nowhere near enough to get to 1.5 or 2 degrees, okay? So honestly, right now, we're probably choosing between 2.5 and 3.5 degrees C, okay? So it's really great to talk about 1.5 and 2, but we would have to have a lot more transitions than what we have right now to get there. And if we want to avoid more than 1.5 degrees, we really have to start cutting CO2 emissions now, and they have to go down substantially before 2030. So here's some trajectories that kind of show you what we would have to do, which I realize yeah, if I skip that other figure, which shows you how much the emissions were going up before. Let me show you how they're going up here. So this is how emissions are going up right now, okay? So they're going up really steeply, and it's CO2 that really matters. There's other constituents as well, but the CO2 in the atmosphere is what stays in the atmosphere for thousands of years and is accumulating right now and causing the problem. We have this huge increase right now, and we need to stop increasing that and go to a very radical decrease here. And so pretty much within the next 10 years, we have to get the technologies implemented and deployed at a large scale so that we can start dropping CO2 extremely quickly. So for this particular study, they use integrated assessment models, which are just kind of very simple models of economies and how much emissions you need to support the people there. And the blue areas are ones that don't overshoot, okay? And the gray ones, delay the CO2 cuts a little bit, but then they have to have more negative emissions down here. So right here is the 0 line. And so, at 2050, we have to be at 0 net CO2 emissions. We have to, stop going up and actually go down. And if we delay by 10 years, we're going to have to start drawing down more CO2 somehow, okay? And then, methane emissions, black carbon emissions, those kind of naturally go down because they're combustion-oriented. Nitrous oxide emissions are associated with agriculture. It's very difficult to bring those down. So, one of the issues is that we have these tools for renewable energies to move us over to a low-carbon economy. But for agriculture, for example, sustainable ag, we don't have all the technologies available. For some parts of industry, we don't have those technologies available. Aviation, there's whole sectors that we don't have the technology available to switch over, and that's one of the reasons that it'll be hard to reach these targets. So they go through in this figure and talk about the different ways that we can reach the really low targets. And I want to point out this P1 here, there's no overshoot going on. So we reach 1.5. And there's very little of this yellow BECS, it's called. So let me tell you more. So the gray is the fossil fuel and industry. AFO is the agriculture, forestry, and other forms of land use, okay? So that's, any kind of land part. And then the BECS is the bioenergy, carbon capture and sequestration. So what that is basically, putting out in large parts of the Midwest, this would have to be, you have to think of it, put out some kind of grain, take that grain, turn it into maybe ethanol, burn it, okay, and sequester the carbon into the ground. So when the plant grows, it sequesters the CO2, okay, and then you're taking that CO2 and you're putting it into the ground and generating some energy at the same time, okay. So, if we wait and try to still reach 1.5 later, we have to deploy so much of this yellow, right, this BECS, almost as much negative emissions in the future as we're emitting now out, okay? So we'd have to have the same kind of infrastructure that we have now to emit fossil fuels, sucking the CO2 into the ground and putting it down, okay? It's a huge deployment, let's just put it that way. If we use current technologies, we would have to use land-based bioenergy, and so it would take a huge amount of land, for example, in the United States, okay? Most of the Midwest would have to be devoted to bioenergy in order to match these targets here. And so that would, move any food production off those lands, and it, or could impact food security, or it will impact biodiversity, because you're going to take all the rest of the native lands out and put them into agriculture. So this has huge environmental implications if you went with this kind of back. Now, this is what all the models use, because it's the only existing technology for carbon dioxide removal. But as many of you know, I'm very excited about trying to develop new carbon dioxide removal techniques here at Cornell, because we really need them to get to some of the low carbon targets. So hopefully we would have better methods of doing it. But at this point, this kind of level of bioenergy, of BECS, to keep the temperatures down below 1.5, we might choose not to do it because it would have such large environmental hazards, okay? It's just such a hard thing to do. It would be very expensive, and it would probably damage the land so much. So this scenario could keep us below 1.5 a little more easily, right? Because it lets us wait a little bit before we turn down the CO2, maybe a little more reasonably. But on the other hand, it takes a huge amount of BECS to pull down that carbon. Now this scenario over here looks really appealing because it doesn't require so much BECS. But what happens in this scenario that's really, really important is behavior change, okay? To reach the target of 1.5 degrees C without this huge deployment of BECS, it means a transition in our behavior. And it's a really radical transition in our behavior. Basically, everybody here in this room at Cornell, as well as on the whole planet, basically goes vegan, okay, or some other sustainable way to eat, never drives a car, never flies, never buys anything. I mean, the behavior side of the climate change problem is really, really important. And the best way to reach low climate targets is, of course, to reduce your energy demand. I mean, there is no source of energy that does not have environmental implications, okay? So you really want to think about the behavior changes, and that's the only way that we can reach the 1.5 in these models. And these models are pretty optimistic. And so these simulations that they got here, you can only get them in these integrated assessment models if you set them up very carefully, basically, okay? Otherwise, you can't reach the 1.5 target in some of the models. It's a very aggressive change. So the rest of the report was really talking about how do we pull together the tools and get the energy around trying to strengthen the global response to climate change. And and combine it with sustainable development and efforts to eradicate poverty. And we really were trying to look for the synergies. I mean, there's so much potential for trade-offs here, right? If you make the energy expensive, you'll stop the efforts to eradicate poverty. We don't want that. Okay, so the report did not talk very much about those kind of trade-offs, but instead tried to focus on pathways that would allow for synergies, okay? And try to put forward a portfolio of options that would allow for more synergies. Now, of course, every location is different, and so that has to be made, location by location, how to reach these targets. But really try to look for the synergies is really important. So there's a whole mix of measures to adapt to climate change too. I mean, we're not, even at 1.5, we have to adapt to climate change. So we're not just going to mitigate against climate change, we have to adapt to the new situation. And, we want to make sure we're adapting in a way that doesn't harm us, okay, in other ways. For example, a good way to adapt to heat waves is to air conditioning. Okay, but that's really bad for mitigation, right? So you want to try to look for options that have more synergies than that. And then we really need to have solutions that work at the lowest, community level, the individual level, the city level, state level, national level, and international level. It's really, this is going to be such a hard task to keep the climate change risks down that we're going to have to work on all levels. And there's a lot of discussion about what kind of scenarios and portfolio of efforts will work in that. And international cooperation is a critical part of limiting warming to 1.5. I mean, if you think about what we have to do in the developed world, in the rich, technologically capable world, here, we've got to develop cool new technologies, get them cheap, deploy them large scale so they become cheap, and then get them out to the developing countries so they don't have to emit all the CO2 we did, and yet they can still eradicate poverty, right? We need to try to disperse the technology as fast as possible. And these are the kind of efforts that we talk about also in the report. So there's a lot of talking about the Sustainable Development Goals. I don't know if everybody's heard of these, but there's a UN effort to have more sustainable development, and they actually have 17 different areas of action. It's very specific what people should try to do to reach the Sustainable Development Goals. And the first one is no poverty, and the next one is zero hunger. Okay, I mean, these sound like great things for everyone. And so the report also looks then at how the synergies between climate action and these different activities are. So for example, if you use a heavily land-based mitigation method like BACS, that could have implications for food security and reduce your chances of getting a zero hunger, for example. So that would be a trade-off. You got to watch that. And so, like I said, they try to look for areas where there's more synergies. And a lot of those happen in, for example, in the energy demand section. So that's behavior side of things. If you can make your systems more energy efficient, that's really, really important and can make it much easier to meet your goals. So in summary, the 1 degree of warming is what we've experienced already. But it's not impossible to stay under 1.5, but it really requires a complete retooling of our economy. We already need to adapt to our current level, and at 1.5 degrees or higher, we're going to have to adapt more. It's very ambitious to reach 1.5 or 2 degrees, which is what we were supposed to look at in this report. We have to move to sustainable energy now. Maybe faster than possible, but we got to do it as fast as we can. We have to change our behavior now. That really makes everything much easier. We have to use less energy, less agriculture, buy less things, all those things. We need to move to a more sustainable agricultural system. And we need to develop the carbon dioxide removal technologies, because the current technologies that we have really important negative impacts. So the report identifies many potential trade-offs between climate policy and sustainable development. For example, we need to make sure we're not trying to deploy expensive technologies, okay, and forcing people, who have no energy now to go straight to an expensive energy source. We have to provide a cheap energy source so that they can eradicate poverty, so they can have a little energy, okay? So we don't want to block countries from developing or eradication of poverty. And the report really tries to focus on identifying the synergies between the climate action and other goals. And there are a lot of synergies. If you move off of fossil fuels, for example, your air quality will get a lot better. A lot of the air pollution we have today is from the burning of fossil fuels. Right away, you see a benefit. I mean, one of the problems with climate change is that we're acting now and we're spending all this money now for the future's benefit, okay? We're really preventing 4 degrees C at 2100. It's an intergenerational equity problem. And so we try to focus on some of the co-benefits that happen with a tight climate policy. And one of the right away is air pollution. And arguably, it's one of the reasons that China is acting to move to renewable energy so quickly, is they realize how terrible their air pollution is and how it's impacting their economy, okay? And so we try to identify all these potential synergies: clean air, clean water, and biodiversity if we have more native lands that can sequester carbon, afforestation, reforestation. These are all things that have benefits now as we implement them, but will also benefit the future in terms of the climate change. All right, thank you.